Welcome to Echo 302, Study Session 7, Investment and Equilibrium in the Product Market, the IS Relation. Introduction. The last lecture showed that an important determinant of investment is real interest rate. We also know that investment tend to increase if either real interest rate falls or income rises. In our aggregate expenditure model, investment is one of its strongest components. For aggregate expenditure to increase, it must be the case that investment must increase. For investment to increase, income must rise or real interest rate must fall. However, when income rises, consumption and investment demand will rise, thus mounting pressure on the real interest rate to rise. This implies that there is a particular real interest rate that will justify the effectiveness of income. The product market is where production of goods and services take place. It includes agriculture and manufacturing sectors. Activities in these sectors are strongly driven by income and interest rate. For instance, increase in income will increase production in both sectors. But we have just discovered that there is a relationship between income and interest rate. What is the real interest rate sufficient for income to exhaust the output produced? How can the level of interest rate and income for which real sector is at equilibrium be determined? This is what we're going to deal with in this chapter. Objective. At the end of this lecture, you should be able to 1. Conceptualize IS curve. 2. Appreciate the importance of IS curve and its policy implications. And 3. Articulate the graphical exposition and understand the key policy variables in IS relation. The IS relation. Income expenditure model is a useful vehicle for introducing the ideal of aggregate investment. We have demonstrated that investment is a decreasing function of interest rate and an increasing function of income. We will make further assumptions that firms borrow from banks so that interest rate will be the only relevant function in this model. With this caveat, we can write investment function as follows. I equals I of R, or I prime of R, which is less than 0. How does this impact on equilibrium national income? For a given interest rate R, we know that equilibrium income Y asterisk will be Y asterisk equals C of Y asterisk plus I of R. That is equation 7.2. Y asterisk equals C of Y asterisk plus S of R. That is equation 7.3. Hence, S of Y asterisk equals I of Y asterisk. That is equation 7.4. Equations 7.2 and 7.4 tell us what equilibrium income will be for a known real interest rate. If interest rate changes, equilibrium income will equally change. To see R, take total differential of equation 7.4. S prime of Y asterisk D Y asterisk plus I prime of Y asterisk DR. That is equation 7.5. Solving for a change in equilibrium income as a result of a change in real interest rate would generate equation 7.6. dy asterisk divided by dr equals I prime of R over S prime of Y asterisk, which is less than 0. which implies that the relationship between interest rate and income for which the product market is at equilibrium is negative. The mechanism goes thus: a higher interest rate reduces planned investment and planned aggregate consumption, the former being the result of high cost of investment and the later being high opportunity cost of holding money. These two effects will reduce aggregate expenditure demand. The relationship between R and Y asterisk. The relationship between R and equilibrium income, implicitly given by 7.2 and 7.4, is known as the IS, that is investment saving curve. The locus of the combination of equilibrium income and R, which satisfy the equality of savings with investment. The graphical derivation of IS curve is given by figure 7.1 below, with R naught being the existing interest rate. Investment expenditure worth I naught was carried out. Given equation 7.4, savings worth S naught must also be made. With this level of savings at S naught, output level Y naught must be carried out. What this implies is that for the economy to produce Y naught level of output, S naught amount of savings must be made. With this level of savings brought about by interest rate at I naught level of interest rate, Y naught level of output will be produced. When interest rate rises to R1 by equation 7.1, investment spending will fall to I1. For equation 7.4 to O, then, savings must also fall. Thus, this causes a downward movement from S0 to S1 in quadrant 2. As a result of low savings, the amount of output that can be produced is given by Y1. This level of output is traced to quadrant 4 and eat a line coming from quadrant 1 at R1, Y1. We see that the point gives the combination of equilibrium interest rate and equilibrium income for which a given level of output is produced. When interest rate is R1, the sufficient income that will ascertain equilibrium in the product market is Y1. When interest rate is R0, the sufficient income level for which goods market is at equilibrium is Y1. Generally, at high interest rate, income will have to fall commensurably to ascertain equilibrium in the product market. Conversely, at low interest rate, income will have to rise commensurably to ascertain equilibrium in the product market. If we continue to assume arbitrary interest rate and find a corresponding income level, a downward sloping curve, as in quadrant 4, will be established. A curve like this is called the IS curve. It is the graphical representation of the product market equilibrium condition, showing the interest rate, savings, and output at equilibrium. We can also conceptualize IS curve as a combination of equilibrium interest rate and output that leaves product market at equilibrium. Algebraic derivation of IS curve. Assuming a sufficiently simple form of S of Y and I of R. In particular, let the behavioral equation for S of Y and I of Y be specified as follows. S of Y equals minus A plus 1 minus B in bracket times Y. That is equation 7.7. I of Y equals E minus HR. Equation 7.8. where A is the exogenous savings, B is the marginal propensity to consume, E is the autonomous investment, and R is the interest rate. Substituting equation 7.7 and 7.8 in 7.4, we have minus A plus 1 minus B in bracket times Y equals A plus E minus HR. Equilibrium income Y equals 1 over 1 minus B times A plus E minus ER, which gives us equation 7.9. Equation 7.9 gives the IS function. It is easy to verify that is negatively sloped. To be sure, differentiate equilibrium income Y with respect to R to get dy asterisk over dr equals minus H over 1 minus B less than 0. Note that H is the marginal propensity to invest, while 1 minus B is the marginal propensity to save. Thus, equation 7.10 replicate equation 7.6 and they together with the graphical exposition tells us that IS is negatively sloped. Quadrant 4 can be carved out from figure 7.1 to see clearly the slope of the IS curve. This is done below. Comparative static. Note that the IS curve indicates that changes in interest rate will cause a movement along the IS curve. Other factors will cause the entire IS curve to shift parallel to A itself or pivot inwards or outward as the case may be. The variables that will cause IS curve to shift parallel to itself are the pure autonomous variables like A and E. The variables that will cause IS curve to pivot are H and B. Let us consider the direction of change of output to changes in some of these variables. Take a change in E, that is autonomous investment first. dy asterisk by dE equals 1 over 1 minus B, which is greater than 0. This implies that a change in E will positively shift the IS curve. That is, a reduction in the magnitude of E will reduce the activities of the product market at a particular interest rate. Conversely, an increase in the value of E at a particular interest rate will raise the volume of product market. In the case of our graph, the former change will shift IS curve inward, while the later change will shift it outward. All these changes are represented in the graph below. Now let us consider a change in the induced variables. Let H change from a particular value, say H0 to H1. The derivative of this change is given by dy asterisk by dH equals minus R over 1 minus B less than 0 and also greater than 0. By inspection, the intercept on the R-axis falls Y on the Y-axis remains unchanged, and so IS pivots down around the point, implying that at a given interest rate, a high age will lead to high income equilibrium. This is represented graphically below. What equation 7.12 shows is that the increase in induced investment H at a given positive interest rate reduces equilibrium income, and the amount by which income falls depends on the size of R. To see this clearly, assuming that dy asterisk by dH equals 0, to find the amount by which income will change at the interest caused by a change in the induced investment, we take the derivative of y asterisk with respect to r. So d by dr of dr asterisk over dh equals minus 1 over 1 minus b, which equals minus 1 over b in bracket to power minus 1. Meaning that dy asterisk by dh falls as r increases. But since dy asterisk by dh is negative, equation 7.13 says that dy asterisk by dh becomes more negative as r increases. This means that the fall in equilibrium income resulting from an increase in age is greater. The higher is r, and the fall in equilibrium income caused by decrease in age is much less the smaller the r. Other parts to note. From our conceptual analysis, IS curve is a locus of equilibrium point. It shows the combination of interest rate and income which equate demand to supply in the goods market. Thus, at any point in the IS curve, supply equals demand. Consider what will likely occur if we have a point such as A or B in figure 7.5. This situation is similar to what happens if there is excess demand or excess supply. Excess demand exists when aggregate expenditure exceeds actual output or when planned investment is greater than planned national savings. In figure 7.5, equilibrium output Y naught is produced given the going interest rate. Any point A before Y naught along R naught line will lead to excess demand, and this signals to firms to increase production. Thus, any point to the left of IS curve holding interest rate constant will lead to excess demand, mount pressure on output, causing inventory to fall and forcing firms to increase production. On the other hand, a point like B on the R naught line implies that planned aggregate expenditure is less than actual equilibrium output, or savings is greater than investment. In a case like this, inventory will build up, leading to downward pressure on investment and hence reduction in output. Therefore, to the right of the IS curve, holding interest rate constant, excess supply will emerge, and by implication, this will lead to reduction in output. This process will continue until Y asterisk, that is equilibrium income, is reached. Summary. IS curve is the line connecting all points of interest rate and corresponding income for which goods market is at equilibrium. IS curve is downward sloping, indicating that as interest rate falls, equilibrium output rises. A change in autonomous spending on consumption or investment will shift the IS curve parallel to itself. A change in the marginal propensity to invest increases equilibrium output and decreases equilibrium interest rate. A point to the left of the IS curve, leaving interest rate constant, leads to excess demand. This causes disequilibrium in the product market, and to restore, output will have to increase through increase in investment. A point to the right of IS curve along the interest rate line leads to opposite scenario. This is the end of study section 7. Thanks for listening.